Hello everyone. Welcome to this unsupervised machine learning from First Principles course. My name is Houston Mzamindo and I'll be taking you the principles of unsupervised learning. I am an applied mathematician, a data scientist at a specialist bank here in Johannesburg, South Africa. I'm the founder of IQ Mates, which is an education platform that is providing free to cheap supplementary resources to students, mostly based here in South Africa. As I'm recording this, we reached our 17,100 students. I'm also the head tutor of a course offered by University of Cape Town called Business Analytics. It is offered via a platform called Get Smarter. Because of my efforts in my startup, I was awarded the TEDx Johannesburg 1830 Fellowship. And I'm also a Udemy instructor. This is actually my second course. My first course focused on supervised machine learning, and it's called Supervised Machine Learning from First Principles. So what is machine learning? I think if you look at an unsupervised machine learning course, you probably know what machine learning is, because unsupervised is I think the second phase after learning supervised learning. As you can see from this diagram here, many people start off with supervised learning, and that is where your data set has labels. So you want to diagnose a disease, you have all the features, and then there's a label of what disease it is. Customer retention, you have the features of all the customers. Let's say the way they interact with your website, how many logins they have, did they buy any new products and stuff like that on your website. And at the end you have a label to say, did the person churn or not? Did they leave, or did they stayed with you, or did they cancel their subscription, their account, or whatever? So supervised learning, you have a label. Market forecasting, maybe you want to forecast house market, what the price will be for a house. When you're training your models, you have a label, the prices of the houses. But in unsupervised learning, you do not have labels. So you just have a data set, but you're not quite sure of what the label is. You actually do not know what the label is. And you're supposed to uncover the information hidden inside that data set. So things like structured discovery, very, very important. Recommender systems. How does Netflix recommend their videos to you, or their movies, or YouTube? YouTube is a very classic example. How does YouTube recommend the next video for you to watch? Customer segmentation. Not all customers are the same. So how do you segment your customers into meaningful groups so that you can apply things like targeted marketing? So under clustering, very, very important. And these are the things we'll be discussing in this course here. But why should we discuss those? It's because of the expansion in data being produced in the world. So if you look at this infographic here, you will see that we have YouTube, and that was in 2016. We had in 2016 72 hours of new video being uploaded every minute to YouTube. Emails being sent, 204 million messages being sent every single minute, 277,000 tweets every single minute. And this data is very unstructured. It does not have a structure to it. It does not have labels to it. But you are supposed to analyze that data, because there's just so much information in there that if we do not come up with methods to analyze it, we are missing out on rich data. Because it is super, super rich. Imagine Facebook users, they share 2.46 million pieces of content every single minute. So that is rich information, and we need methodologies to analyze it. Here, this is an infographic from 7 June 2016. Imagine now in 2020 how much these numbers have changed. Because as we know, countries in continents like Africa, where I'm from, many devices started coming online. People started getting Android devices, and many people started accessing the internet. Mobile devices became their first way of accessing the internet. Cheap Androids coming out of Asia enable that. So many people could now Google, now create Facebook accounts, could now access videos via YouTube. You know, yeah, we still have Skype in there, but yeah, Vine long dead. See how this feels like a long time ago. Imagine now how this has changed. Let's look at some statistics from 2020. It's saying that the big analytics market is going to reach 103 billion by 2023. That is huge. That is huge. In 2020, every person will generate 1.7 megabytes in just 1 second. And that makes sense because on WhatsApp, let's say you receive an image or you send an image or you take a picture, that's already 12 megabytes or whatever it is that you have just generated in that instant. So every person who is generating close to 1.7 megabytes every second. Looking at the other statistics at the bottom, you can go to the link here and actually read up on more statistics like this. 90% of the data has been created in the last 2 years. And like I explained, many people jumped online, devices could connect, the data prices fell, and there was a lot to do on the internet, a lot more to do on the internet. Platforms like WhatsApp came on, and people just jumped on board, stopped sending SMSs, now started using WhatsApp. Today, it will take approximately 108 million years to download all the data from the internet, and it's only going to get more and more. WhatsApp users, they exchange up to 65 billion messages a day. Billion messages a day. That is incredible scale. And like I'm saying, that data is unstructured. It is text, it is video, voice notes, or images. Unstructured data. And in this course, we are going to learn how to deal with that data. Because in supervised learning, you have much cleaner data. You have your labels, you have your good table, you clean it up, you train with the label, works well. But with unstructured data like an image, how do you work with an image to analyze the information behind the image? Those are some of the principles we'll learn here from an unsupervised learning point of view. Using some of the techniques, we are not going to get into deep learning, which provides even more tools to deal with that data. I will have a course for deep learning from first principles, but this is just unsupervised learning. This is a very important part that I want to highlight. 80 to 90% of the data we generate today is unstructured. So which means all that data set that you can use, let's say for me, I work in a bank right now, right? I work in a bank. Most of the data is going to be your transactional data when people swipe their cards. That data set is pretty much structured. It is structured data. But 80 to 90% of the data is unstructured. It's your videos, your images, your voice notes, your voice calls, your text messages, your emails, unstructured data. And we need to analyze that data set if we are going to come up with very, very good insights. And 95% of businesses cite the need to manage unstructured data as a problem for their businesses. And that makes sense because when you have all these emails, you're communicating with your clients, most of that information is lost in that unstructured nature. Or you have a live chatbot, or you have your calls, you have a call center. There's a lot of interaction with clients that is lost in that unstructured data. So you need ways to uncover insights in there. How do you best service your clients if you do not understand what they're saying to you? And it will be difficult. Sometimes it's difficult because of your scale. It will be difficult for you to analyze each and every email, each and every call manually. It might be difficult. So you need some algorithms to help you do that. And these are the algorithms that we'll be discussing in some of this course. And like I emphasized, there are much more powerful algorithms to do it under deep learning. But for now, we just do the basic ones. And when we do the deep learning course, you see much more better ways of dealing with that unstructured data. So like I said, in this course, we'll be focusing on this part here, unsupervised learning. We're going to do customer segmentation, dimensionality reduction. We're going to do all that, clustering. Actually, let me show you what we're going to do. In this course, we're going to first look at supervised learning versus unsupervised. Because supervised learning is a good base for us to build our knowledge for unsupervised learning. If you've taken my course, the supervised learning from first principles, firstly, thank you for doing that. And then secondly, that supervised learning is a very, very good base for you to jump onto this course now. We are going to discuss the differences, and we are going to build a supervised learning fraud detect, let me say we're going to build supervised learning for detectors using different algorithms under supervised learning. So your logistic regression, your random forest, XGBoost, and LightGBM, they all fall under supervised learning. We are going to use those, and we get the results. We're going to keep the results on the side, because what we're going to do now is we're going to use unsupervised learning algorithms to see if we can improve on those fraud detectors that we would have built from supervised learning. We're going to try build on top of them, or build completely different versions of the fraud detectors using unsupervised learning techniques. Which techniques, you might ask? Principal component analysis, the different types. Your normal one, your sparse PCA, your kernel PCA. We're going to look at those. We're going to do SVD, random projections, isomaps, MDS, LLE, TISNI. I call it TISNI. I don't know how many other people pronounce it, but I call it TISNI, and ICA. And we build the anomaly. We build anomaly detection algorithms, or rather anomaly detection systems using these algorithms, and we'll compare them with our supervised learning. Has unsupervised learning performed better than supervised? What if we put the two together? First unsupervised, then supervised on top of that. Those are some of the exercises that I'm going to urge you to do on the side, but the codes are going to be there. Clustering, we are going to use k-means, hierarchical clustering, and DB-scan, or HDB scan. We are going to segment a client base for different use cases like your marketing, because you know, although you might have people who would come to your gym, so you might say all of them are just fit people, they want to use the gym, but inside there could be clusters. There could be people who just want to use the weights. There could be people who come there just for cardio. When I go to the gym, I only do cardio. I very rarely do weights. I usually just focus on cardio. If you want to advertise a new class, you probably don't want to just send it to everyone, because if it's a weight class, I might not read the email. I'll be disinterested. So you want to target the right type of clients, and segmenting your client base using these methods here will help you do exactly that, so you can talk to the right client at the right time. And then feature extraction. Sometimes when we're doing supervised learning and supervised learning and all of those, you need to come up with your own features, or do a bit of feature engineering. That is a very, very taxing process, because you need to have, let's say, domain knowledge. When you're coming up with a fraud detection system, what features are you going to look at? And that needs domain knowledge. Are you going to look at the transactional history? Are you going to look at the amounts? Are you going to look at how many transactions? Are you going to look at the average? Are you going to look at some other features? Are you going to create your own features? You're going to use logarithms. Are you going to do this? So it becomes very, very taxing. So they actually say there's a rule, or an unwritten agreement in machine learning, that 80% of your time goes to that. It goes to you massaging the data set for it to be ready for your algorithm at the end. The algorithm part is the easiest part. The hardest part is massaging it in a way that can be ingested by the algorithm to give good insights. But with feature extraction, like using things like autoencoders, you can use an autoencoder for it to learn the structure of the dataset and come up with its own features to represent the dataset in a way that might make your algorithm at the end there much better, perform better, without you having to do all the feature engineering yourself. You can do auto feature engineering, and that's what we'll be learning in that section. So the resources I'll be using, of course, the information I might reference will come from my supervised machine learning course that you'll find here on Udemy. I'll be referencing a textbook called Introduction to Statistical Learning, very good basis textbook, and I reference it quite a lot in the supervised machine learning course, because it teaches you the basics of supervised learning. And the mathematics, if I have to reference a mathematical principle, it will come from Elements of Statistical Learning. It has heavy maths in it, but it's a very good book for you to study if you're interested in the mathematics behind some of these algorithms. And I'll be talking about from different articles, journal papers that I would have read. And attribution to the core content is given to this book here you find on Amazon. It's called Hands-on Unsupervised Learning Using Python. So the codes that are in point number 6 are coming from that book that was written by A. Patel. And I just changed them to suit, let's say, some of the concepts that I'll be putting together from my other course and this course. So I just shifted things around. But otherwise, I think the core of this course is coming from that book, and I urge you to buy that book. An extremely good book. Extremely good book. I wouldn't emphasize it enough. Extremely good book. So now that we have gone through the introduction of this course, in the next video we're going to just get into supervised learning versus unsupervised learning. So I would say let's start learning. Let's get learning. See you in the next chapter.